Good morning, everyone. My name is Adriana Rosales, and I'm in charge of the RF systems and testing engineering of this project.
Hi, I'm Bailey. I was in charge of finding the LTE signal and researching the protocols for 4G.
Hi, my name is Harsh Patel, and I was in charge of the autopilot and also the hardware for the rover.
Hi, my name is Sergio Orjuela, and I worked on the system architecture and the geolocation.
Good morning, my name is Fasazion. We design an autonomous system that tracks a cell phone signal. Our system is a proof of concept. Our sponsor, Los Alamos National Lab, will take the project and use our design for much better, much larger system. I developed the graphical user interface, in short GUI, and the GUI is the main control. I also work on the MAVLinks, the protocol. The protocol connect the Arduino with the autopilot. Our system can be used in many applications. For example, we can use it in law enforcement to track and capture a fugitive based on his or her cell phone signal. Now, my friend Sergio will go over with the system.
Thank you, Fish. So I'm going to be talking a little bit about how the system actually works. So the first thing is the user plugs in a wireless module to their computer and opens our graphical user interface, which you can see a screenshot of right here. On that GUI, he's able to see the location of the rover and the location of the cell phone signal if it is found. So what we're using to find the signal is we're using a trilateration algorithm that takes the rover's position as well as the signal strength. And basically, because the signal strength is relative to the distance, we use a little bit of geometry to get the location. So given that, what we were able to accomplish with our system is we were able to not necessarily get the signal strength from a cell phone. However, we were able to get the signal strength from a cell phone tower, which was enough for us to test our system and validate our proof of concept. Next, Harsh is going to talk a little bit about the actual rover.
So for our project to follow the tracked device, we implanted our system on the ground rover, but we can easily implant that also on a drone or UAV. Our system is fully autonomous, as you can see in this video, that it is following each waypoints one by one autonomous. We have mounted SDR, software-defined radio, mini computer, Arduino, and Pixox on top of the rover, as right here. And the rover is communicating with the graphical user interface using MAVLinks. And now Bailey will talk about the 4G LTE.
Really quick, so we focused in on the RCC protocol for LTE, which will show the signal strength between the eNode B and the phone, as well as other towers around to ensure that it's connected to the strongest. We used OpenLTE to do this. We were unable to actually connect with the phone because of our computer power as well as how secure the network is, but we were able to find towers around areas. And Adriana will talk really quickly.
So for the communications part of our project, we wrote two codes in Arduino, a receiver and a transmitter code. The transmitter code allows the user to input a certain coordinate, while the receiving code allows to receive that coordinate that the user input. And our system was used by a small part hardware called Moteno RF69, which was connected to our own Odroid, which is the Odroid mobile computer that we have. So we made it easier to connect to the laptop, and the laptop is connected to the little rover car, which that made it easy, accessible, and more effective and quick. And that was the part of the communication software project.
Does have any questions?
Any questions?
Any questions?
During your design of this, did you go through some type of design project review during it in like a stage gate type process?
We did with Los Alamos, and one of the things they wanted us to really be safe is we didn't want to interfere with other cell phone networks, so
Mhm.
everything was tested in an environment where no signal got in or got out, and it was tested within a Faraday cage.
Okay. That's good.
Okay.
Any more questions?
So actually, it wasn't clear to me that you completed the project as originally scoped.
We had to keep reiterating, so what Los Alamos originally wanted is they wanted 3 drones to create a sort of system to do the trilateration. But we reiterated through 3 different software-defined radios, and the final one was about $1,200, and the complexity was getting a lot higher. We'd need a directional antenna, so we had to narrow it down to something that we could do. And the main purpose was to essentially prove that it is possible to trilaterate a cell phone using the signal strength. And although we weren't able to use this, the actual cell phone, we were able to do it with a cell phone tower.
And it'll actually be finishing up this summer with Los Alamos. Sure.
And maybe just to, so the issue that Sergio mentioned is that they have a $2,000 budget limit for the project. So
Yeah.
we just couldn't let them buy multiple radios at $1,500 each.
Multiple drones.
Yeah.
During the design phase, there were multiple reviews done with the Los Alamos people. They interacted on a weekly basis as every other project. And there was an agreement to scale down to the current state with the Los Alamos mentor.
Oh, we have one question.
One last question?
Quick
Oh.
question. So, nice presentation. You had to work with a lot of constraints. What was your performance metric, and did you meet it?
What were the requirements?
Right, so our performance metric is, it's to prove the concept. Is it possible to track a cell phone, right? So we looked at the literature, and as a part of the 4GE LTE procedure, the cell phone is actually sending its signal strength. And it does that because it needs to coordinate the logistics between switching cell phone towers. So we know it is possible to gather the signal strength because in part of the protocol, it is sending the signal strength. But we weren't able to get it because we didn't have the processing power or the right hardware. But we were able to take, I guess, a mock signal strength from a cell phone tower, and that was enough to, I guess, prove our proof of concept.
But did you have requirements on the accuracy that you need to track?
No, we did not. But our accuracy is probably within 100 meters, and our range is about half a mile.
All right.